All right, this would be the type number 6. It's an additional station to the same parent function we've already looked at. And so these ones are what we call exponential. And in our case, in this one, we're going to focus on the graph over here. This is what we call exponential decay. So this is a decay problem. So what's going to happen is the graph is going to get smaller and smaller as we go to the right. So there is no parent function for like any decay. It could be basically y equals a to the x, but that value of a has to be some value between 0 and 1. Right, so in our case, it'll probably be represented as a fraction. In our case, we're going to use y equals 1/3 to the power of x. And we do want to put that in parentheses, otherwise it looks like the 1 is getting the exponent, and really it's the whole fraction that gets the exponent. So basically what I want to do is I'm going to plug in these values of x in for x and see what we get. So we're going to get 1/3 to the power of -1 if we plug in -1 for x. And remember, a negative exponent flips the fraction, so it becomes 3/1, which is the same thing as 3, right? Then we're going to have 1/3 to the power of 0. And if we remember from our exponent rules, anything to the power of 0 is equal to 1. And then we have 1/3 to the power of 1, which is just 1/3. So I'm going to plot those points on there. I have x's and y's. So I have -1, 3. I have 0, 1. And I have 1, 1/3. And so I'll get a graph that looks like this. And that's what exponential decay looks like. And so what I notice is that I cannot cross over. It doesn't matter what number I plug in for x. I am never going to cross over that dotted line. So that's going to help you figure out the domain and range of this graph, which is what I want you to do now in your groups.